In the last lectures of discussion, we have already derived 33 formula on integration using different types of functions, in which we have already derived integration for sin x, cos x, tan x, then sec x, then cosec x and cot x. Today we have to derive certain formula on trigonometric functions, which are the composite functions. That is, we have derived integration for sin mx, cos mx, tan mx, cot mx, sec mx and cosec mx. So for this purpose we have to use algebraic substitution. So let us start with today integration of trigonometric functions by algebraic substitution. So let us first consider the function, that is the integrand. Integration of sine of mx with respect to x. Here sin mx is a composite function of trigonometric function and algebraic function, that is mx. So for this purpose we have to substitute mx as v. So let us substitute mx as v. Mx is equal to v, that is v is equal to mx. So v is a function of x. So we have differentiated v with respect to x. So differentiating v with respect to x, we get m into 1, because m is the constant and derivative of x with respect to x is equal to 1. So we got m into 1. So we have dv by dx is equal to m. Again simplifying, we have dv is equal to m into dx. So again simplifying, dx will be dv by m. So after substitution and differentiation, so we got ds as dv by m. So replacing in the integrand, we have integration of sine of v in place of mx, in place of ds let us put dv by m. So we got integration of sine v with respect to v by m. So here the variable of integration is v. So 1 by m is the constant and it can be taken out of the integral. So taking 1 by m out of the integral, we can write as 1 by m into integration of sine v with respect to v. But we have already integrated sine v with respect to sine x with respect to s, that is minus cos s plus c. So integrating sine v with respect to v, it will give us 1 by m into minus cos v plus c, where c the constant of integration. So again simplifying, we got 1 minus 1 by m into cos v plus 1 by m into c. So again replacing v as mx, we got minus 1 by m into cos of mx. So in place of 1 by m into c, we can take k, where k is the constant of integration. So in this process we got a formula for integration of sine mx, that is we got integration of sine of mx with respect to x is equal to minus 1 by m into cos of mx plus k. So this is the formula that we can remember it for integrating the trigonometric functions connecting with the algebraic function. So we got a formula for integration of sine mx dx as minus 1 by m into cos of mx plus k. So now let us consider some examples in solving using the formula, that is consider example 1. Suppose we have to integrate integration of sine of 7x with respect to x. So it is in the form of sine of ms with respect to x. So integrating sine of 7x with respect to x, it will give us, here m is as 7, so we can write minus 1 by 7 into cos of 7x plus c. So using the formula, that is integration of sine ms with respect to x. So m is 7. So we know integration of sine mx with respect to x minus 1 by m cos ms plus k. So using that formula, we can write in place of m as 7. So we got minus 1 by 7 into cos of 7x plus c. So again consider another example, that is integration of sine of 5 by 2 with respect to 5 by 2x with respect to x. So here 5 by 2 can be taken as m. So in this process, integrating sine of 5 by 2 with 5 by 2x with respect to x, it can give us minus 1 by 5 by 2 cos of 7 by cos of 5 by 2x plus the constant c. So again simplifying, it can give us minus 2 by 5 into cos of 5 by 2x plus c, where c the constant of integration. So using the formula integration for sine ms with respect to s, we can integrate such composite functions involving the trigonometric functions, and we can easily integrate by using this formula. Now let us consider the second integral, that is integration of cos of mx with respect to x. Here cos mx is also a composite function of trigonometric function and algebraic function. So let us substitute mx as v. Let us substitute or put mx as v, that is v is equal to mx. So differentiating v with respect to x, it will give us dv by dx is equal to m. So again simplifying, we have dv is equal to m into dx. So again simplifying, dx will be dv by m. So let us substitute in place of mx as v. So we have integration of cos v. So in place of dx we have dv by m. So after substitution we got integration of cos v with respect to v by m. So here m is the constant of integration. So taking 1 by m out of the integral, we have 1 by m into integration of cos v with respect to v. Now integration of cos mx ds was not in standard form for integration, but now integration of cos v with respect to v is in standard form for integration. But we know integration of cos x ds is sin x plus c. The same process, integration of cos v with respect to v will be 1 by m into sin v plus c, where c the constant of integration. So simplifying, we have 1 by m into sin v plus 1 by m into c. So again replacing v as mx, we have 1 by m into sin of mx plus k in place of 1 by m into c, where k is the constant of integration. So now the integration is over. So we got a second formula in this process, that is integration of cos of mx with respect to s is equal to 1 by m sin of mx plus k. So we have to remember this formula for integrating the composite function, that is trigonometric function, and algebraic function, that is integration of cos ms with respect to s is equal to 1 by m into sin ms plus k. So using this formula we can also solve some examples, like that is in example 1, consider integration of cos of 4x with respect to s will give us 1 by 4 sin of 4x plus k, where k is the constant of integration. Similarly, we can integrate integration of cos of 1 by 2 x dx, and it will give us 1 by 2 into sin of 1 by 2x plus constant k. Again simplifying, it will give us 2 into sin of 1 by 2x plus k, where k is the constant of integration. Now let us derive the third formula, that is integration for tan of mx with respect to x. So let us consider the integrand, that is integration of tan of mx with respect to x. Here tan mx is a composite function of trigonometric and algebraic function. So before integration, let us substitute or put mx as v, then dv by dx is equal to m. So simplifying, we have dv is equal to m into dx. So again dx is equal to dv by m. So now substituting v in place of mx, the integral will be tan of v. In place of ds we have dv by m. So taking 1 by m out of the integral, we have integration of tan v with respect to v. So now integration of tan v with respect to v is in standard form, and its integration is 1 by m into ln of 1 by m into ln of sec v mod plus c, when c the constant of integration. So integration of tan x with respect to x is equal to ln of sec s mod plus c. So in the same process, integration of tan v with respect to v will give us ln of sec v mod plus c. So simplifying, we have 1 by m into ln of mod of sec v mod plus 1 by m into c. So again simplifying, we have 1 by m into ln of sec of, in place of b, let us take ms, sec of ms mod, plus in place of 1 by m into c, we can take k, where k is the constant of integration. So in this process, we got the third formula, that is integration for tan ms with respect to x. That is, we got integration of tan mx with respect to x is equal to 1 by m into ln of sec of mx mod plus k. So we have to remember this formula for integrating the composite functions like trigonometric function and algebraic function in the form of tan of mx with respect to x. So using this formula, we can solve examples like, suppose integration of tan of 6x with respect to x will give us, here m can be taken as 6, so we have the integration like this, 1 by 6 into ln of mod of sec of 6x mod plus k. So also we can take another example, that is integration of tan of 7 by 3x with respect to x will give us 1 by 7 by 3 ln of mod of sec of 7 by 3x mod plus k. Again simplifying, it will give us 3 by 7 into ln of mod of sec of 7 by 3x mod plus k, where k is the constant of integration. So we derived and we became able to solve some of the examples on integrating the trigonometric functions like using the formula that is tan of mx with respect to s. So we completed the problem. Let us derive the formula for integration of cot of mx with respect to x. So we have integration of cot of mx with respect to x. Here cot mx is a composite function, combination of trigonometric function and algebraic function. So before integrating, so let us substitute or put mx as v, then v is equal to mx. So v is a function of x, then differentiating v with respect to x, we got m. So again simplifying, we have dv is equal to ma into dx. So we have dx is equal to dv by m. So replacing, we have the integral, that is integration of cot of v. In place of ds, we have dv by m. So the non-standard function, that is integration of a cot ms, transformed into the standard form, that is integration of a cot v with respect to v by m. So taking m as a constant, so we have 1 by m into integration of cot v with respect to v. So now integration of a cot v with respect to v can be integrated using the formula integration of cos x with respect to, whose integration is ln of sin s mod plus c. So integrating cot v with respect to v, we have 1 by m into ln of mod of sin v plus c, where c the constant of integration. So again simplifying, we have 1 by m into ln of mod of sin v plus 1 by m into c. So replacing v, we have 1 by m into ln of sin of mx mod plus k. In place of k, that is we have taken 1 by m into c as k, where k is the constant of integration. So we became able to integrate cot mx with respect to s. We got the fourth formula, that is we got integration of cot of mx with respect to x is equal to 1 by m into ln of sin mx mod plus k, where k is the constant of integration. So we got the fourth formula in the process of integration. So we can use this formula in integrating so many functions which are in composite form. For example, let us consider in example 1 integration of cot of 9x with respect to s, which will give us 1 by 9 into ln of sin of 9x mod plus k. Also another example, we can integrate like integration of a cot of 1 by 2x with respect to x, which will give us 1 by 2 into ln of sin of 1 by 2x mod plus k, where k the constant of integration. So finally simplifying, it will give us 2 into ln of sin of half x mod plus k, where k the constant of integration. Now let us derive the next formula for integration, that is integration for sec of mx with respect to x. So sec mx is a composite function combination of trigonometric function and algebraic function. So in the process of integration, let us substitute mx is equal to b, that is b is equal to mx. So b is a function of x. So differentiating b with respect to x will give us only m. So simplifying, we have dv is equal to m into dx. So again simplifying, we have dx is equal to dv by m. So now replacing in the integral mx as b, we have integration of sec b. In place of ds, we have dv by m. So now we transform into integration of sec b with dv by m, where 1 by m is the constant, because b is the variable of integration. So taking 1 by m out of the integral, we have 1 by m into integration of sec b with respect to b. Now integration of sec b with respect to b is in standard form for integration. It can be integrated using the formula integration of sec x with respect to x, which give us 1 by m into ln of sec b plus tan b mod plus c, where c the constant of integration. Also it will give us 1 by m into ln of 1 by m into ln of tan of pi by 4 plus v by 2 mod plus c, where c the constant of integration. So in the process of integration, we have two formula for integration of sec mx with respect, that is one is 1 by m ln of sec v plus tan v mod plus c. The another formula is 1 by m ln of tan of pi by 4 plus v by 2 mod plus c. So we have two results. So replacing v, we have 1 by m into ln of sec of mx plus tan of mx mod plus k. So 1 by m into c can be taken as k, where k is the constant of integration. Also we have the second formula, that is 1 by m into ln of tan of pi by 4 plus, in place of v we can take mx by 2 mod plus 1 by m into c can be taken as c k, at the k is the constant of integration. Then let us derive the last formula, that is integration of cosec mx with respect to x, which is integration of cosec mx with respect to x. So let us consider the last formula, that is integration of cosec mx with respect to x. So the integral, we have cosec mx with respect to x. So cosec mx is also a composite function of trigonometric and algebraic function. So it is not in standard form. So to bring into or to transform into standard form, let us substitute or put mx as v. Then differentiating v with respect to x will give us m. So again simplifying, we have dv is equal to m into dx. So again simplifying, we have dx is equal to dv by m. So now substituting in the integral, we have integration of cosec, in place of ms we have v, in place of ds we have dv by m. So taking 1 by m out of the integral, we have 1 by m into integration of cosec v with respect to v. So now integration of a cosec v with respect to v is in standard form, and it can be integrated by using the formula, that is integration of cosec x with respect to s, and its integration is 1 by m into ln mod of cosec v minus cot v mod plus c, where c the constant of integration. Also we have another result, that is 1 by m into ln of tan of v by 2 mod plus k, where k the constant of integration. So again replacing v, we have 1 by m into ln of cosec mx minus cot of mx mod plus 1 by m into c. So again, simplifying the second formula, we have 1 by m into ln of tan of mx by 2 mod plus 1 by m into k. So finally, simplifying we have 1 by m into ln of cosec mx minus cot mx mod plus k, where k is the constant of integration. Again, simplifying the second formula, also we have 1 by m into ln of tan of mx by 2 mod plus c, where c is the constant of integration. Now we have already derived 6 formula in this lecture, and these are the important formula for us, and we have to remember those formula. So the first one is, that is integration of sine ms with respect to s is minus 1 by m into cos of ms plus p. Then integration for cos ms with respect to s is equal to 1 by m into sine of ms plus c, where c is the constant of integration. Then integration of tan of ms with respect to s is 1 by m into ln of mod of sec ms plus c. Then we have derived for integration of cos mx with integration of cot ms with respect to x is equal to 1 by m into ln of mod of sine mx plus c. Then for integration of sec mx, we have derived 2 formula. The first one is 1 by m into ln of sec ms plus tan ms mod plus c. Then the second one is 1 by m into ln of tan of pi by 4 plus mx by 2 mod plus c. Then lastly, we have derived for integration of cosec mx with respect to x, which is equal to 1 by m into ln of cosec mx minus cot ms mod plus c. Also the second one is 1 by m into ln of tan of mx by 2 mod plus c. So these formula are very much important for us. Remembering this formula, we can solve so many problems on integration when we face a composite function combination of, that is Trigonometric function and the algebraic function. So we have to remember this formula very carefully. Now in the process of integration by substitution, we have already derived 24 formula on integration. Also in the previous classes, we have also derived 15 formulas. So in total, yet we have derived 39 formula on integration, and those formula will be very helpful for us in integrating the forthcoming integrands or functions. But now let us try to integrate some trigonometric functions. So there are certain trigonometric functions and with those functions are not in standard form for integration, and if we try to integrate those functions, we have to transform those functions into standard form by using the sum or difference of trigonometric ratios of compound angles. So in this process, let us recall the sum and difference of trigonometric ratios of the compound angles. Let us recall the trigonometric ratios of compound angles, that is sine of a plus b is equal to sine a into cos b plus cos a into sine b. So the second formula is sine of a minus b is equal to sine a into cos b minus cos a into sine b. So we have sine of a plus b is equal to sine a into cos b plus cos into sine b. Again we have sine of a minus b is equal to sine a into cos b minus cos into sine b. So also we know that cos of a plus b, which is cos a into cos b minus sin a into sin b. Also we know that cos of a minus b is equal to cos a into cos b plus sin a into sin b. So we have 4 formula on trigonometric ratios of compound angles. Here a plus b and a minus b are termed as the compound angles. So we have 4 formula on trigonometric ratios of compound angles. So in the process of integration, we have to remember those formula along with the sum and difference of the trigonometric functions, that is sum and difference of trigonometric ratios of such compound angles, and these are, let us find one by one. That is, we have sine of a plus b plus sine of a minus b. So we have sine of a plus b is equal to sine a into cos b plus cos into sine b. Also sine of a minus b is equal to sine a into cos b minus cos a into sine b. So adding, we have, so cos into sine b minus cos into sine b cancelled. So we have 2 sine a into cos b, 2 sine a into cos b. So in the process of integration, if we place a function in the form 2 sine a into cos b, it can be transformed into sine of a plus b plus sine of a minus b. Here 2 sine into cos b is not integrable, but its form, that is sine of a plus b plus sine of a minus b, is integrable. Then we have sine of a plus b minus sine of a minus b. It will give us sine of a plus b minus sine of a plus a minus b will be, so it will be sine a into cos b minus sine into cos b plus cos a into sine b plus cos a into sine b. So sine a into cos b minus sine will be cancelled after subtraction. So it will give us 2 cos a into sine b, 2 cos a into sine b. Again we have in 3, that is, let us add cos of a plus b along with the cos of a minus. So we have cos of a plus b plus cos of a minus b. So adding, we have, so minus sine a into sine b plus sine a into sine b cancelled. So we got cos a into cos b plus cos a into cos b, which is equal to 2 into cos a into cos b. Again in 4 we have, so taking the difference, that is cos of a plus b minus cos of a minus b, we have cos of a plus b minus cos of a minus b will give us, so subtracting, we have cos into cos b minus cos into cos b cancelled. So we got minus sine a into sine b minus sine, which is minus 2 sine a into sine b. So again changing this formula and multiply minus on both sides, it will give us cos of a minus b minus cos of a plus b. So multiplying minus on the both sides, so we will find a minus as plus, that is cos of a minus b, and it will be minus cos of a plus b. So in this process, minus 2 sine a into sine b will be plus. So we have 2 into sine a into sine b. So in this process of integration of trigonometric functions, so we have to remember those 4 formula. So if we have an integrand in the form of 2 sine into cos b, it can be transformed into sine of a plus b plus sine of a minus b. If we have an integrand in the form 2 cos into sine b, it will be transformed into sine of a plus b minus sine of a minus b. Also, if the integrand in the form of 2 cos into cos b, it will be transformed into cos of a plus b plus cos of a minus b. Again, if the integrand in the form of minus 2 sine a into sine b, it will be transformed into cos of a plus b minus cos of a minus b. Again, if the integrand in the form of 2 sine a into sine b, it will be transformed into cos of a minus b minus cos of a plus b, where the right sides are not integrable, where the left sides are integrable. So we can integrate using this process. So in the process of integration of trigonometric functions, we have to remember all this formula, so that it will be very helpful for us integrating the forthcoming functions in integration. So in the process of integrating the trigonometric functions, there are generally 4 types of integrands of trigonometric functions. Those integrands are not in standard form for integration. So before integration, we have to transform into standard form by using the sum or difference of trigonometric ratios of compound angles. So let us consider the first, the type 1 integrand, that is, we have type 1. So in the type 1, in the process of integration, we may come across 3 types of integrands, that is sine mx into sine nx. Number 2, we may come across cos mx into cos nx, or we may come across sine mx into cos nx. So in type 1, we may face with 3 types of integrands. The first one is sine mx into sine nx, the second one is cos mx into cos nx, the third we may face sine mx into cos nx. So these are the trigonometric ratios of multiple angles. So in the process of integration, these integrands are not integrable. So you need to integrate and transform to standard form. So we have to follow the following process. So let us consider the first one. Consider the first one, that is sine of mx into sine nx. Sine of mx into sine nx. Here the integrand sine mx into sine nx is not integrable. So in order to integrate it, we have to transform into 2 sine a into sine b form. So we have to multiply 2 and divide by 2 with the integrand. That is, we have half into 2 sine mx into sine nx. We have sine of mx into sine nx. So multiplying 2 and half, we got half into 2 sine mx into sine nx, which in the form of 2 sine a into sine b. So it can be transformed into but we know that 2 sine a into sine b is equal to cos of a minus b minus cos of a plus b. So we have cos of mx minus nx minus cos of mx plus nx. So we have 2 sine mx into sine nx, which in the form of 2 sine a into sine b, which is cos of a minus b minus cos of a plus b. So in place of mx we have a, in place of nx we have a b. So we have cos of mx minus nx minus cos of ms plus nx. So again simplifying, we have half into cos of, taking s out, so we have ma minus n into x minus cos of ma plus n into x. Now see the function, that is cos of ma minus na into x minus cos of ma plus ns is integrable. So the original integrand, which was sine mx into sine ns, was not integrable. So you need to integrate after transforming using the trigonometric ratios of sum and difference of compound angles. We reach that half into cos of ma minus na into s minus cos of ma plus ns, which is easily integrable. Easily integrable. So we can integrate the function. So this is the general theory of how to integrate the function of the type sine mx into sine nx. Now let us consider the second one, that is consider the second one, that is cos of mx into cos of nx. Here cos mx into cos nx is not integrable. So to integrate it, we have to adjust, that is multiply half and also multiply 2 with it, cos mx into cos nx. So now 2 cos mx into cos ns in the form of 2 cos into cos b, so which can be transformed into half into cos of mx plus nx, ms plus ns plus cos of mx minus nx, because so 2 cos mx into cos nx is in the form of 2 cos into cos b, so which is cos of a plus b plus cos of a minus b. So now we transform it into cos of ms plus nx plus cos of mx minus nx. So taking s out of the factor, we have half into cos of ma plus na into x plus cos of ma minus n into x. So now the original function, that is cos mx into cos ns, was not able for integration, but after transforming into this form, which is half into cos of ma plus ns plus cos of ma minus n into s, it is now easily integrable by using the formula cos of mx with respect to x. So now the transform function, which is half into cos of ma plus n into s plus cos of ma minus n into s, can be integrated by using the appropriate formula for integration. Then let us consider the last one, that is sin mx into cos nx, and how we can integrate it. Let us see. So consider the third function, that is sin of mx into cos of nx. Now, so the integrand may come in the form of sin mx into cos nx, which is the product of two trigonometric functions in the form of multiple functions. So it is not integrable. So we need to integrate it. We have to adjust by multiplying half and 2. So we have 2 into half into 2 into sin of mx into cos of nx. So we have 2 sin A into cos B. But 2 sin A into cos B is equal to sin of A plus B plus sin of A minus B. So we can break like this: 2 sin mx into cos nx as sin of mx plus nx plus sin of mx minus nx. So 2 sin mx into cos nx is in the form of 2 sin A into cos B, which is in the form of sin of A plus B plus sin of A minus B. So we have sin of ms plus ns plus sin of ms minus nx. So now taking x as common, we have half into sin of ma plus n into s plus sin of ma minus n into x. Now see, the transformed function, which is half into sin of ma plus n into s plus sin of ma minus n into x, both the integrands, that is sin of ma plus n into x and sin of ma minus n into s, are easily integrable by using the formula, that is integration of sin ms with respect to x, which is minus 1 by m cos ms plus c. So now we have already derived the theoretical concept on integration of trigonometric functions in type 1. So we have 3 types of integrands. So using that knowledge of integration, so now let us try to integrate a function, that is integration of sin 3s into cos 2s with respect to s. So consider, so let us see how we can solve this problem. So we have integration of sin 3x into cos 2x with respect to x. So now see the integrand. So integrand the form sin 3s into cos 2s, which is not in the standard form for integration. So we have to transform into such a way that it can be easily integrable. So let us apply the process, that is we have to multiply 2, so that it will be 2 sin 3s into cos 2s, which will be in the form of a 2 sin A into cos B. So we have to multiply a half, so that is half into integration of a 2 sin 3x into cos 2x with respect to x. So now the original integrand transformed into 2 sin 3s into cos 2s with respect to s, which is in the form of 2 sin A into cos B plus 2 sin A into cos B is equal to sin of A plus B plus sin of A minus B. So transforming, we have half into integration of sin of, here A is 3s, B is 2x. So we have sin of 3x plus 2x plus sin of A minus B, that is 3x minus 2x whole integration with respect to x. So now we have 2 sin A into cos B, which is sin of A plus B plus sin of A minus B. This integrand is not integrable, but after transforming into this form, it can be easily integrable. So we have, after simplifying, half into integration of, we have sin of 5x plus sin of x with respect to x. So now we find that sin of 5s plus sin of x with respect to. So now using algebra of integration, we have half into integration of sin 5s with respect to s plus half into integration of sin x with respect to x. Now in the both the integrands are easily integrable. So sin 5s can be integrated by the formula sin mx, and sin s is also easily integrable. So integrating, we have half into, so integration of sin 5s will be minus 1 by 5 cos of 5s plus c1 as a constant of integration. Again the second integrand, we have half into, so integration of sin s is minus cos s plus c2 as the constant of integration. So now the integration is over. Now we have to simplify to reach at the final result, that is we have multiplying minus 1 by 5 with half, it will give us 1 minus 1 by 10 into cos of 5s plus half into c1 plus minus half into cos x plus half into c2. So again simplifying and collecting the constants, we have minus 1 by 10 into cos of 5x minus half into cos x, and collecting the constants, we have half into c1 plus half into c2. So finally we have minus 1 by 10 cos of 5x minus half of cos s plus k in place of half into c1 plus half into c2. So k the constant of integration. Again if we simplify, finally it will give us, taking minus 1 by 10 as common, it will give us cos of 5s plus 5 cos x plus k at the constant of integration. So in this process we became able to integrate a complex function into the standard form, and the integration is now over. So now in the second problem we have to integrate integration of sine 2s into sine s with respect to s. Here we have product of two trigonometric functions, and this integrand is not in the standard form for integration. So we need to transform into standard form. We have to transform like this way, that is, let us consider the solution of the integrand, that is integration of sine 2x into sine s with respect to x. So it is sine a into sine b. So if we multiply 2, it will give us 2 sine a into sine b, and we have to multiply half to make the adjustment. So 2 sine a into sine b is nothing but cos of a minus b minus cos of a plus b. So we have multiplying half out of the integral and multiplying 2 inside the integral. We have 2 sine 2x. We have 2 sine 2x into sine s with respect to x. So in the process multiplying half and 2, we got 2 sine 2s into sine h. So we transformed into 2 sine into sine b. But 2 sine into sine b is nothing but cos of a minus b minus cos of a plus b. So we have half into integration of cos of 2x minus x minus cos of 2x plus x whole integration with respect to x. So here if you see 2 sine 2s into sine s is not able for integration, but after transforming into the form cos of 2s minus x minus cos of 2s plus s with respect to s, both the integrands are easily integrable. So simplifying, we have half into integration of cos x minus cos of 3x whole integration with respect to x. Now simplifying and using algebra of integrals, we have half into integration of cos x with respect to s minus half of integration of cos of 3x with respect to x. Now both the integrals are easily integrable, and integration of cos s with respect to s is sin s plus c. So similarly we can integrate cos of 3x with respect to x. Now integrating, we have half into, so integration of cos x is sin x plus the constant c1, again minus half into integration of cos 3s can be integrated by using the formula cos of mx, whose integration is 1 by m sin mx plus c. So in this process integration of cos 3s will be 1 by 3 into sin of 3s plus c2 as constant of integration. Now the integration is over, but we have to simplify the obtained function. So simplifying, we have half into sin s plus multiplying half with c1, it will be half into c1 minus 1 by 2 into 1 by 3, which is 1 by 6 into sin of 3s minus half into constant c2. Now collecting the functions and the constants separately, we have half into sin of x minus 1 by 6 into sin of 3s plus collecting the constant, that is half c1 minus of half c2. Finally we got 1 by 2 sin of x minus 1 by 6 into sin of 3x plus k in place of 1 by 2 into c1 minus half c2, where k is the constant of integration. So in this process we we completed the process of integration and we got the final result, that is half sine s minus 1 by 6 sine 3s plus k, where k is the constant of integration and the integration is over now. Then let us try to solve the third integrand, that is we have to integrate cos of 4x into cos 3s with respect to s. So consider the problem. For solution we have integration of cos of 4x into cos of 3x dx. Now let us see, cos 4x into cos 3x is not in standard form for integration. So to transform into standard form, so we have to adjust and multiply half and 2. So we got half into integration 2 cos 4x into cos of 3x with respect to x. So now we have 2 cos 4x into cos 3x. So assuming 4x as a and 3x as b, we have 2 cos into cos b. But 2 cos into cos b is equal to cos of a plus b plus cos of a minus b. So applying that formula, we can change the formula, that is we can change the integral like this: cos of 4x plus 3x plus cos of 4x minus 3x with whole integration with respect to x. So here see, we have 2 cos 4x into cos 3x, which is in the form of 2 cos into cos b. So transform into sum of two trigonometric functions. We have cos of a plus b plus cos of a minus b. So here we have cos of 4x plus 3x plus cos of 4x minus 3x. So then simplifying, we have half into integration of cos of 7x plus 4x minus 3x is cos x. So we have integration of cos 7x plus cos x with respect to x. Now both the integrals are easily integrable by using the formula of integration of cos mx and cos x. Now applying algebra of integrals, we have integration of cos of 7x with respect to x plus also half into integration of cos x with respect to x. Now integrating cos 7x, we have half into 1 by 7 sine of 7x plus constant c1, again half into integration of cos x is sine x plus c2 as the constant of integration. So now the integration is over, but now we have to simplify the final result. So we have 1 by 2 into 1 by 7 is 1 by 14 into sine 7x plus half into c1 plus again we have half into sine x plus half into c2. Now collecting the functions and the constants separately, we have 1 by 14 into sine of 7x plus half into sine s plus half into c1 plus half into c2. So now taking common 1 by 14, we have sine of 7x plus 7 sine x plus in place of half c1 plus half c2, we can take the constant, that is k, where k is the constant of integration. So in the process we have already completed the integration, so the integration is now over. So now in the process of integration of integrating trigonometric functions, we have already completed how to integrate trigonometric functions of type 1. So in the next class we will try to solve and derive how the technique how to integrate trigonometric functions of a type 2. So thank you for the next class.